All right, so welcome back. We're going to continue where we left off last week. Last week we talked about, I think last 2 weeks of the first lecture, I introduced you what IoT is, and the TA was good enough to also run us through some basic practical of things that we'll be doing in the practical section. Now, last 2 weeks, I remember telling you these are the topics that we'll be covering in this course, or yes. So as that we've already tackled lecture 1, of which the TA has started at least introducing some few components to you. In today's lecture, we're going to cover lesson 2 or lecture 2, which is architecture and domains. So this particular lecture is quite big. I'm hoping we could finish today. If not, then maybe we'll try and complete it possibly tomorrow or next week. But I think we should be using the Wednesdays for the practicals and Tuesdays for the online class. All right, so let's begin with today's, which is architecture and domain, which is lecture 2. Now, there is no such unique or standard consensus when it comes to um, most of the IoT architecture, there is a sample that most of them, build around. So we don't really have a unique or a standard one, but there are some basic things that virtually all these architectures should have. Now, when we talk of the IoT architecture, it differs from their functional area and the solution of which the IoT is meant to tackle. But in this case, the architecture itself consists of about 4 main components. So these are the components. I'm sure the TA has made mention of some of them. And I think the last time too, I spoke about some of the introductory class for the Internet of Things. So the components of the IoT architecture are the ones that have been outlined in here. We have the sensor, we have the gateway and networks, we have the cloud management. I talked about all these last week. We have the application layer itself. I will delve into each one of them and give very good explanation to it. So sensors are devices that detect and measure physical property or changes in the environment. So just like the temperature sensor, it detects and measures the temperature physical environment. So that is what sensors we usually that is what they are meant for. They detect, they measure physical properties or changes in the environment. That is what sensors, that is what they do. And most times they also convert these physical phenomena into electrical signal that can be read and also processed by a computer or a controller. Because we are dealing with IoT, I think most of the things that we'll be talking about will be related to controllers. And I remember giving you examples of the controllers that exist. So first of all, the sensors, they detect and measure physical property in our surroundings. And based on that, they are able to convert that physical property into electrical signal. Of course, if it is being fed, it's going to feed it into controller. It needs to be converted to a digital signal, which is the electrical signal that we talk about, because computers understand zeros and ones. Now, the examples that we outlined here were for the sensors, we have the temperature sensor. I'm sure you have seen one by now. We have the pressure sensor, the light sensor, proximity sensor, and accelerometer. That is also an example. For the temperature sensor, obviously what it does is it measures temperatures. And for the pressure sensor, it's also going to measure pressures. The light sensor has the measurement of light intensity, and the proximity sensor detect the presence or absence of an object. So that is where the infrared sensor comes in and ultrasonic sensor comes in. The accelerometer also measures acceleration or vibrations in objects. So these are some basic sensors that exist. There's a difference between a sensor and actuator. You know, we can see from here, we have sensors and actuators. I know that TA spoke to you about actuator. So please, who can tell me what the actuator is meant for? What is it meant for? Peter Mo? Peter Mo? What did the TA say about actuators?
Hello.
Yes. Yes. Peter?
Sir.
Yes. I forgot it. Okay.
Sir, I'll come back.
You'll come back.
Okay.
All right. Yeah, so let me just put up this so we can. Yeah, so we have the sensors and actuators. That is where the sensors, there are a lot of them. Well, when we talk of actuators, they are devices that convert the electrical signal into physical actions or movements. The sensor, what it does is it detects and measures, and the actuators are meant to convert the electrical signal into physical action or movement. So, for instance, um, if you have a light sensor, um, it detects the intensity of light. The moment it sees the lights, maybe a switch should be turned off. So in this case, the actuator is the action that happens in here. So there are devices that convert the electrical signal into physical action or movement. So for instance, if we have a motor in our circuitry and based on maybe temperature change, the motor should swing. So that is where the actuator comes. It's what it does is that device that is able to convert the electrical signal into the physical action, which is the rotating or the rotation of the motor, is the actuator. So they usually take commands from the computer processor and perform a specific task. They are involved in motion or control of mechanism. So when you hear of actuators, you should have in mind that, you know, exactly that is what upon is also saying. It converts energy into motion. So that is what actuators has. They are mainly used in the control of a mechanism, either to rotate something or to move something in any way. So there are other examples of actuators to that exist. We have the electric actuator, which is an actuator. And what it does is it converts electrical energy into a rotational motion. So that is how come when you have the motor and you have wires to maybe a battery, you see the motor turning off. So that is an electric motivator. And what it does is it converts electrical energy into a rotational motion. The hydraulic cylinder will use pressurized fluid to also use linear motion. Um, there are lots of these actuators that exist. I think you'll be in the practical session, you'll get to know most of. So usually the sensors and actuators they go hand in hand. That is in terms of the architecture, that is how the architecture actually really do look like. So these things come together to form the IoT. Now, of course, we'll talk about the purposes of each of them. I just wanted to clarify on the sensors and also now, in terms of the stages of the IoT architecture, there are several layers of IoT built upon the capability and performance of the IoT element itself. And usually they provide the optimal solution to most of the businesses and also the end users you can see. So generally, IoT architecture itself is the fundamental way to design virtually the almost all the various elements of the IoT. So in this case, it can deliver service over the network and also serve the need for the future. There are stages of IoT that provide the architecture itself. So the following are the primary stages or layers, as you can see over here, of IoTs that provides the solution for the architecture, for the IoT architecture itself. Sensors and actuators, I'm going to now hit on each of them. So in an exam or a quiz, if you are told to, give a very good explanation to the architecture itself, I expect you to have this in mind. But let's talk about the sensors and the actuators. Now you know the difference between actuators. Let me hit on each of the primary stages that goes through in the architecture itself. So for the sensor and the actuator, what the sensors and actuators do is that, of course, they are devices, and what they are is to emit, accept, and also process data over the network. So they do the emission and the acceptance and processing of data over the network. Network in the sense that for IoT to exist, we need access to a network. When most times it has to be, in the based on the earlier lecture. So these sensors and actuators may be connected either through a wireless medium or a wired medium. From your, is it computing technology? For a network to exist, you have usually 5 main components that come together to form that makes a network, come to life. The components are the sender, the recipients, the message, the channel or the path or the transmission medium, and also the final one, which is the protocol of which the data will be transferring. So now, in terms of the channel, what route are we going through? So that is where this comes in. The sensors and actuators that you see in here, they may be connected to the network either via a wired cable or a wireless network. So with a wired cable, it could be like I think this Daniela has first about this. You can see in the installation of cameras, cameras are linked to, they get connected. There is a port that, the IoT cameras, they usually have a port that can take the RJ45, which is a network cable. So we can connect to it and it will be sent to the right place for into network. So for all these cameras to get access to. So the actuators and the sensors may be connected either through the wired or the wireless. Some of the wireless cameras, they only get connected wirelessly through the wireless cards to maybe the through the modem or maybe the routers that exist. So most times these usually contain the GPSs, the electrochemical, and also the RFIDs. And most of the sensors usually need connectivity through sensor gateway. So that is where we'll come into the sensor gateway, So the connectivity actuator can be through a local area network or a personal area network. The local area network is when you set up a network, maybe in a cable or with in a wireless signal, you could have a local area network being set up. So most of these connection for the sensor and actuator, they always area network so that these devices will be able to talk to each other. For the personal area network, I'm sure you are aware, you see PAN or personal area network, that is usually the connection that we normally use for personal area network is the Bluetooth. Is it only electrical energy that's it's come? Maybe you might have to get to know what it means. Yes, for the gateway and data acquisition. Well, don't forget, these are the primary stages of IoT in terms of the architecture. So for the gateway, most times, as large number of data are produced by the sensor and also the actuator, there is also a need for high-speed gateways or network to transfer this particular is being pushed through. So if the data that comes to these actuators or sensors is quite high, and the bandwidth that is going to serve this data to the cloud is slow, you can imagine how long it would take the data to go to the cloud for analysis. So usually, um, when the number of data, which is by these sensors and also these actuators increase, then we have to, or there should be a need to have a high speed gateways and also networks to enable a seamless transfer of data when it comes to this. So usually the network can be local area network, and it could be a Wi-Fi, or it could even be the internet approach, that is the use of the cable or the wireless. Sometimes too, it goes beyond that, the local area network. So the point where we have the wired, in this case, we can have a GSM, the 5G, and so on. You know, some of these talked about when we get into the practical. There are some few things that we'll be talking about. Now let's talk about the next one, which is the Edge IT. The IT here stands for Internet Technology, or the Internet Technology, using usually the technology. So the edge in the IoT architecture, as you can see, is usually a hardware and a software gateway that's analyzed and also process the data before transferring it to the cloud. So I'll give an example of this particular thing. So be briefly about this. Usually when we talk about the edge IT, it's the hardware and the software gateway that analyzes and also pre-process the data um, that is being received by the sensor. Then based on that, when it does the pre-processing, then transfer it to the cloud. So if the data read from the sensor and the gateway and changed from its previous reading values, does not transfer it onto the cloud. And this usually stays the data which is being used. So the edge is very key in a sense that if a situation where, for instance, if I should take an example like I've configured my system that every 5 minutes it should take the temperature of the room. The sensor is supposed to take the temperature of the room. So on first count, on the first 5 minutes, if the temperature is about, let's say, 40 degrees Celsius, it processes the edge IT, does the processing because the value is 40 degrees Celsius. It does the processing, does the analysis, do a pre-process and pushes it to the cloud. So that is the first data that it has. Now, after 5 minutes, if the same, after 5 minutes, if we still get, let's say 40 degrees Celsius again, what it does is, it's now, first of all, it analyzes the value that we have with the new value, which is the 40 degrees Celsius. It pre-processes it and it realizes that indeed there is no change in value. So this time round, instead of pushing the data to the cloud, it doesn't push it because already there is no change in value. So because of this process, the Edge IT helps in, you know, sending the necessary stuff to, the cloud. Natural part, the Edge IT is one thing that is very key when it comes to the architecture of the IoT. So as I said, the Edge IT, the IT itself is stands for information technology, and it's pronounced as the Edge IT. And what it does is it's the application of the information technology at the edge of the network in the IoT architecture itself. So where the data processing and the analysis occur, It's so for instance, the edge is always closer to the acquisition section of the sensor. So if the sensor senses it, captures the data or detects and captures the data, hence the edge. The edge is actually very closer to the sensors and actuators. So analysis and the pre-processing makes it's easy. The transfer doesn't go far. So everything happens at the network section before it goes onto the cloud. By going onto the cloud, that is most times where internet. So the edge is very key when it comes to the architecture of the IoT. So the data center and cloud, that everything happens in there. Usually it comes under the management services, which process the information through analytic, management of the device, and also security. Some of these, the architecture that you see, we talked about it in the introductory lecture as well. So besides this security protocol and device, the cloud transfers data end user application. And usually the end user application could be the retail, the healthcare, emergency, so forth. Now, this is how the architecture itself looks like. And this gives you a general overview of the IoT architecture. So in a typical IoT setup, I'm sure you can see, just a minute. So in a typical IoT setup, please pardon me a little. Let me just. All right, so I just resumed the recording. Let me go over this all over again. Do I go over or I should continue? I just activated the recording. Should I go over? Okay, let me just go over it again. All right, so you have the videos, yes. So this is the IoT architecture, and I'm saying that there are 4 stages of the IoT solution architecture. And at stage 1, we have the sensors and actuators coming in. Stage 2, we have the internet gateway data acquisition system. And we have stage 3, which is the edge IT itself, and stage 4, which is the data center and the cloud. So these are the 4 main stages that exist. And the stages comes directly from here. These are the stages. All right, so now let me hit on each of them. But generally, in any typical IoT setup, various devices and sensors are meant to collect data from the environment. And the data that is often gathered is processed and also analyzed in a way that we'll be able to retrieve meaningful information or insights or to trigger an action. That is where the actuator do come in. Actuators over here in step 1. So the traditional approach, the basic olden approach, usually involves sending all collected data to a central cloud server where the processing and analysis usually occur. That is a traditional approach. I think in the first lecture, I gave the traditional approach of how IoTs operate. Now, in this case, if we were to embark on the traditional approach, that is where we send all the data that we collect at the stage 1 to the cloud through an internet. There is this bottleneck that I talked about. That is a disadvantage because we might have to consume bigger bandwidth, and also this will increase costs. And also, we can also have a high latency. You can imagine if at every point in time we are sending data to the moment we get the data, we take it to the cloud. We get the data, we take it to the cloud. So it means there is a continuous usage of the bandwidth. So in that case, we will consume the bandwidth so much. And in doing so, We have this new architecture where we have the stage 2 and stage 3 being placed in there to simplify things. And that is where the edge IT also comes in. And I explained what the edge IT is by giving it, by letting you know what it refers to. And I'm saying that it does the processing of the data because it is closer to where the data is generated. And this is mainly because sending it to the central cloud server is quite expensive. So it refers to the edge IT itself, refers to the practice of processing data closer to where it is generated, rather than sending it all the way to the central server. And in achieving this one, the edge devices are the ones that are responsible for doing this. So we have the edge devices, and most times when we say the edge devices, it's talking about the gateways. And what it does is it sits at the edge of the network. From traditional explanation, we have the IoT devices, with their sensors and all, getting connected to the internet and the internet connected to the cloud. And all the processing goes onto the cloud from first lecture. But this time round, we have the edge IT and the internet gateway coming into place. And we are saying that when we talk of the edge IT itself, it achieves this process through the edge devices. And the edge devices in this case would be the gateways. And this is possible because it sits at the edge of the network, which is between the sensor and the cloud itself. So that is steps 2 and 3 coming in here. So there are some key components of the edge IT itself. And there are 3 of them. We have the edge devices, which is the gateways. We have the sensors. We have the cloud. Those are the key components of the edge IT. So the edge devices itself, or gateway, are the hardware and also the software systems which are located near the IoT sensors. And usually they perform initial data processing and analysis locally without sending it directly onto the cloud. The sensors, what they are meant to do is to collect raw data from the environment. And the data could be temperature, humidity, motion detection, and so on. And finally, we have the cloud itself, which is a centralized server where more comprehensive data processing storage happens. But for the edge, for the component itself, we have the local processing happening at the edge IT itself, which forms part of the components of the edge IT. And I'm saying that it works in these steps. There are 4 main steps when you talk of the edge IT. It's the way it works. And the first step is the data collection. And that is the importance of the sensors. The sensors collect the data from the environment. And the next step is the local processing. That is where the edge devices or the gateways receive the raw data that is being collected from the sensor, then analyze and pre-process the same data in the locally over here. Then an example is what I gave. There might be filters, aggregates, also transform. You could also transform the data in any way. Now, based on the data that is collected and analyzed, we move on to the next step, which is the data comparison. And the data comparison, that is where the edge device compares the current data with the previous data or reading. And finally, we have the conditional data transfer. And at that side, at the conditional data transfer, what happens is if the new data is not significantly different from the previous reading, there is no need transferring that particular data to the cloud. So we don't send it because there is no, we didn't get any meaningful change. And the example I gave was the temperature sensor. If it does measure the temperature and it's 40. For the first start, after 5 minutes, it measures it again and it's also 40. Then there's no change in value. So the pre-processing happens and it's stored here. It doesn't push it to the cloud because the cloud already has the first data, which is the 40 degrees Celsius. But in a situation where there is a significant change, then what happens is, for instance, if it is 45 degrees Celsius, then we will now push it to the cloud. So in situations where there are no significant change, there is a good thing because we don't consume the bandwidth by sending unnecessary stuff to the cloud all the time. So saving of the bandwidth is quite high in this process, and we also reduce the data that is transferred to the cloud. So that is about it. So with this said, I would want one of you to now tell me what you think is the benefit of having the Edge IT in this particular type of design. Just one person. Comparing with the traditional way of the traditional architecture, where we have the IoTs connected to the internet and moving to the cloud for analysis. Yes, anyone? Just raise your hand, I'll give you access. Yes, you. Unmute yourself and talk. Yes. Agatha AJ. My people, are we here? Yes, it saves a lot of storage. Good. Upon that is true. All right. So in terms of the benefits of Edge IT, these are the compressed benefit that we exist. We have the reduced latency, bandwidth saving, cost efficiency, and improved reliability. So reduced latency, that is where the processing of the data locally happens at the Edge IT. And it does so by reducing the time it takes to analyze the data and also responding to the events. This most of the time is crucial when you are thinking about real-time application. Bandwidth saving, that is one other benefit of Edge IT. Cost efficient, sending data to the clouds and now analyzing it locally makes it quite cost efficient. Improve reliability, and in this case, yes, it improved performance too, of course, as well. Thank you, Agatha. Local processing can continue to function even if the connection to the cloud is intermittent or lost. That is the improved reliability. Yes. Yeah, so moving on again to it is faster. Indeed, yes, it is. Yeah, so let's talk about the use of IoT in different domains. When we think about IoT in the domain of energy, the Internet of Things actually plays a vital role in the field of energy management and regulations. So the term used here for that is smart energy system. In the domain. So the domain is the area in terms of the usage of IoT in energy, in the energy domain or the energy area. The term that we normally use is a smart energy system. So in this case, IoT applications, what they do is to monitor a wide variety of energy control functions to residential and also for commercial use. Helps improve data or information. Okay, Bonnie, you're right in a way. Yes. Thank you. Yes, so Now, we are talking about the fact that IoT monitors a wide range of energy control functions at the residential and also commercial use. I've given an example of a residential energy use. This, the use of this type of IoT energy in the area of the residential residence or in our homes. Let me put it that way. So from here, you can see that because technology keeps increasing day by day, it also raises some cost of energy. We have different devices connected um, onto the national grid, doing so many things. We have these IoTs coming in. The moment we have technology increasing day by day, of course, then it means the cost of energy so would go up. And by so doing, consumers normally set the way through which they can reduce the cost and also control the energy cost that is being fed to their individual household. So what IoT can do is to provide a mature way to analyze and also optimize the use of such devices which we have in our homes as the entire system, of a home. So in this case, it may be changing the device setting, simply switching on and off, dimming lights, and also optimizing the energy use. I give an example where if you're traveling, instead of putting your lights on the whole day, even on the daytime, you can perform these basic functions by changing the device setting, the device which is probably connected to the internet. Now it becomes an IoT. So in that case, we can change the setting that when it is 6 p.m., the lights should come on. When it is 6 a.m., the lights should go off. Or we could also say that based on the intensity of light, the sunlight, the light should come on. So whether it's a 6 p.m. or not, if it rains and it becomes cloudy and the intensity of light goes down, automatically the sensor now triggers the data that it has received for the actuator to now put off the light or put on the light or even dim it. So that is an example of the use of IoT in residential areas in terms of energy. So we are able to conserve energy instead of the lights being on 24/7. Because of the use of sensors and actuators, we are able to, reduce the cost of energy. Now, this is a typical example. So we have these home appliances all in here, and they are all connected to a wireless router. So the lights, the air conditioning, security, smart metering system. I think there's a final year guy doing a smart metering system, energy storage, local energy, and so on and so forth. So all these are IoT devices connected to this particular wireless, and they all have in there some sort of sensors and actuators to perform certain tasks at any point in time. So this is the use of IoT in the homes. And I said, we term this as the smart energy system. Now, for this, sorry. So I spoke about the residents. Now for the commercial area too, this is what happens. So energy wastage most times impacts the production of most businesses too. But IoT usually offers an effective way to monitor and also maintain low cost and high efficiency. So it does so by providing a robust means of managing energy consumption cost and also minimizing enterprise output. It's just like the way what I talked about for the residential, the commercial too, is just on a higher scale. So energy can also, the introduction of IoTs in the energy field, IoTs can help, manage the the cost of energy at these commercial areas. So most times what the IoT does is it identifies and also resolve energy issues, which is similar to the functional issues in most of the complex business network. So in a big organization, maybe they produce cars and the rest, IoTs could be used. We will normally term that as robots. The robots that's, at any point in time, if maybe the skeleton of the car has been developed, the moment it's developed, maybe a signal is sent to another device for the device to now look at the design that has been made. Then it's probably sent to a device where a metal crusher is probably molds the car, does other things, fix lights and so on and so forth. So all these things will be done at any point in time in the commercial area. And it makes it more reliable because IoT will ensure that the system reliability through the analytics and also actionable insights. So in this case, it detects the threat to system performance and also the stability. So in the commercial energy center, just like the residential, things that needs to be done at any point in time without human intervention could also be made, and that can reduce, the cost of the wasted of energy in such commercial areas. And you can see it's from here, so you can see we have mobility IoT in a commercial building, mobility and customization, occupants, comfort and environmental control, energy consumption monitoring. We have the board in here, building functionality and area sensors, detailed and actionable reporting. So in the energy world, this can also be done. IoT can help do most of these things so that the cost of production, will be reduced, thereby making the organization make enough revenue based on the work that they do. All right. We've spoken about IoT in the energy domain. So now when we talk about the biometric domain too, these are other IoT also does play a vital role in this area. And it does so by the use of biometric security systems such as the fingerprints system, the voice recognition, and also the eye scanner system. Whenever you hear of biometric, it is not only your fingerprints. There are two main types of biometrics. Anytime you do hear of biometrics, remember that there are two main types of biometrics. The first is the physical biometric, and the second is the behavioral biometrics. So biometric in itself is a measurement and statistical analysis of people's unique physical and also behavioral characteristics. And I'm saying that there are two main types of biometrics. So there's physical biometric and also the behavioral biometric. When we talk of the physical biometrics, they are based on the physical characteristics of each individual. Every individual, it's not just the physical characteristics, it has to be unique. So it is based on the physical characteristics, which is unique to each individual. So with that said, we can confidently say that fingerprint is a physical characteristic which is unique to everybody. So we have the fingerprints, and in this case, with the fingerprints, we have unique patterns of ridges and also valleys in the tip or at the tip of a person's fingers. So that is what makes it so unique. We can't have one individual having more than one individual having the same fingerprints. Even identical twins have their unique pattern of ridges and also valleys at the tip of their fingers. So that is one example of a physical biometric. Now, the next one is the facial recognition. So in that case, what happens is the analysis of the facial features, including the shape of the eye, the nose, the mouth, as well as the distance between these features. I have a long face, so the shape of my eye will be different from another person. Some also have big forehead. So the shape of their faces might be different. The noses will also be different. The mouth design is also different. So that is in terms of the physical characteristics. We can also have the facial recognition as one of them. We have fingerprint facial recognition, and we also have the iris recognition. Iris has got to do with the colored ring of the eye. So it's also the unique pattern in the colored ring of that particular of each individual's eye. We can also have maybe the retinal scan, which is meant for the unique pattern of the blood vessel of the back of the eye. So that is where the retinal scan comes in. The hand geometry itself, the shape and size of the hand and the fingers is also unique. It also falls under physical biometric. DNA is one of the physical biometric, and what it does is the unique genetic makeup of an individual. Every individual has a DNA that is unique. I'm told twins have the same DNA. I don't know how true that is. Anyone has any knowledge in that? I heard it somewhere, but I don't know how true that is. Maybe we could check it out. They don't have the same DNA? Sure, Daniel. I say this because I once watched, let me pause the video and come in again. Okay, well, let me just put it up. I once watched one, I think a judge trying to help people, somebody gets the twins, some twins got a lady impregnated, they impregnated a lady. And based on that, the judge said something about the DNA, because they were identical twins, their DNA are the same. So that is what made me say that. But if it's no, maybe you can check it out. Yes, twins, yes. Twins that are identical, they have the same DNA. So twins, if you are a twin here, please make sure you don't impregnate somebody, the same person. They nearly have the same DNA since they are from the same egg, exactly, upon your right. So that is what the judge said. So they had to now, they couldn't rely on the DNA to know who was the child, who was the father of the child, but rather they had to go in for a lie detector test. That was when they were able to detect. Apparently, one of the twins was lying about having an affair with the other lady. So the lie detector was able to help know who was the actual father of the boy. So in this case, for the physical biometric, it looks like DNA is a little questionable, but it has been listed as one of the physical characteristics which is unique to every individual. So we have the palm print, which is similar to fingerprints, but in this case, Now we've been taking some palm prints. It is larger and it includes the whole palm. We have the ear shape as also one of the physical biometric. And in this case, of course, the shape of everybody's ear is different. The shape and the structure itself of everyone's ear is different. So that could also serve as a physical biometric, which we can use to secure systems in the area of the biometric, IoT biometric domain. Now we have also the behavioral biometrics. In this case, this is based on the behavior patterns, which we believe to be unique to every individual. So an example is the voice recognition. My voice is unique, is a unique feature of a person's voice. It's unique to everybody. But it's funny, now we have people who can mimic, people's voice. Even AIs now are able to mimic the voices of people. You could hear an AI, talking like it's Elon Musk talking. And personally, I've even tried this before where I recorded a sentence, fed it to an AI, gave it about a paragraph to read, and it sounded almost just like me. I had a plan for doing something in that area, so I wanted to see if that is possible. And indeed, the AI spoke very close to my voice. It's just that the way, because I'm not from America, the way I pronounce my words, some of my words were a little different from how the AI pronounced it, but this voice was just about the same. So that's about the behavioral biometric. So, when you are using any of these things, you should be mindful of, the pros and cons. Signature is a behavior thing. The way you sign, if you have a calligrapher, they will be able to sign your signature exactly as you sign. The gait analysis is a unique way of working. Everybody has a unique way of working. If I see some of you, those that have been hitting me up or have been talking to me a lot, even in the dark, when I see you, the way you stand will even let me know it is you. Like the way I saw somebody, a lady standing somewhere in the dark with some guy. Anyway, that was just by the way. We have the stroke dynamics, unique pattern in the way a person type on the keyboard. The way you type to could even serve as a behavioral biometric in this area. So now biometric in itself is something that we can always encounter in our daily life. So we always either use a fingerprint sensor or an eye scanning system. And this is how it works. So you can see from here, when a person places their finger on the fingerprint scanner here, it scans the fingerprints as part of an enrollment process. Usually, before you can know that for the first time when a fingerprint device has been set up, you need to enroll onto the platform so that they can save your data. So it scans it as part of an enrollment process. The device extracts key features from the fingerprints. And this fingerprint is put together as what we call a fingerprint template. And that distinguishes it from other fingers, or the fingers of others, and store it in a database. So subsequently, what can happen is each time the person or the same person places his finger on the fingerprint, the person, what happens is it creates a new template, and that template is compared to the one which is stored in the database. And if there is a match, the system then performs a corresponding action such as recording attendance or allowing access to a door. So that is what happens. So on a first glance, the moment a person puts his finger on the fingerprint device, it goes through the enrollment process where the fingerprints and certain features of the finger is picked and extracted into something we call the fingerprint template. And that template is stored over here in the fingerprints database. And in this case, the moment the person comes again, he's not coming in as an enrollment to enroll, but rather for verification. Of course, the database that you see here could be serving as an attendance system and so on, or maybe a door opening and so on. So the second time he does that, the finger is now pushed in there for verification. So the data is picked. Yes, we can have Isaac's, your hand is up. You can unmute and ask the question. Yes.
Say Bismarck rather, not Isaac.
Okay, Bismarck Waffle.
Say please, I want to ask about the fingerprint. Are the imprints on the fingers the same? I mean, that of, let's say, on my left hand, the thumb, the little finger, then the middle finger. Do they have the same imprint?
Can you come again? Your voice, there is a little echo. If you can get closer to the mic a little.
I'm saying that the fingers, the imprints on the fingers, are they all the same?
No,
Talking of, let's say, okay.
the imprints are different. If you look at even your index finger on the left and the right, they are all different. So
Okay, sir, I'm asking that because I've noticed about more than 4 instances where I'm registering for a fingerprint, and then let's say I use my left middle finger and then continue to the right. They all work in the process.
they all work. That's strange. Okay, now there is one thing that I wanted to talk about here. I'm happy you brought it up. I might have forgotten. Yes, in a security system, especially those you are in second year, those that would be possibly be taking the certified in cybersecurity. There is this thing that we normally put in security systems. So for instance, for the fingerprint device that you see here, if it is mainly meant to open doors, now there is a threshold that the person setting up this particular fingerprint would have to use. So for instance, instead of using about 100% of the fingerprint template to give access to the door, he can set up a threshold of about 70 and above. There are cases where legitimate people, are not given access to, let's say, a company that probably uses a fingerprint system. So there is a security issue when it comes to fingerprints. Now, there are also times where if you reduce the threshold too much, anybody will be able to use the fingerprint system. So for instance, if the threshold has been placed to about 40 out of 100, it means it is about 40% accurate. So if anybody who is not even registered or enrolled on a system brings his finger to the fingerprint device, there's a likelihood he might be given access. So depending on the system that you were working on, and the threshold that has been set on that system, that could have been the reason why you were able to use both fingers and it gave you access. Ideally, it's not supposed to. Most times, because the security experts usually they don't go in for 100% because 100% there are times maybe during the enrollment case we are unable to pick every corner of the finger of possibly the right index finger. So if you use 100% and even the finger is a little wet or whatever, the threshold is 100%, you can imagine that the person might be standing by the door so many and trying so many times and not getting access because the access threshold that was given is quite high. So most times most of these security persons, when they are setting up some of these things, they try not to use the entire 100% to give access to or grant access to some of these doors. So from the example you are given, there's a possibility that the threshold for accepting your fingerprint is quite low. That is how come you're able to use both fingers and it works. Does it make sense? Just let me know if it makes sense with a thumbs up or something, or you can type. Kenaswa Seidu. Okay, Doc, Miss Mark. Okay. So it's actually a security thing that they normally put up. Thank you. So usually that is you can't get 100% thing. If not, a legitimate person might be denied access when you use up the higher percentage. If you use a lower percentage to somebody who is not legitimate to possibly enter an organization, will be given access, to walk straight into your organization. So there are pros and cons. So usually that is how come they try to, if they are increasing the percentage, they normally would want to take at least 2 or 3 of your fingers. So that in a situation where your finger is wet or there's a cut on your finger, the other might possibly work. All right. So that is about the biometric. I think I've given a good example. So, excuse me. All right. So, sorry, that's the explanation for the biometric. Yes. So, class, can we end here and possibly continue next week? I feel very tired right now. But so next week we're going to talk about the same IoT. Well, let me put it this way. I think the information here, it's a little self-explanatory. Would you want me to go through all of them? Maybe on slide 15. So we go through all of them, or you would let's continue, God willing, next week. Are we okay? What are examples of behavioral biometrics? Okay, Kinaswa. Yes, let me give an example. So I spoke about the way you walk. There is this doctor in, I don't know if he's a professor in K University now. He at the time I was there, he was a doctor. He came out with his PhD was centered on this thing, which was the way the biometrics for an example of biometric behavioral biometric. That is the way you walk. I talked about this one. That is this. I spoke about the gait, GAIT analysis. So yes, thank you, Solomon. So there's voice recognition, there is signature, there is gaits, and there is keystroke dynamics. That is the way you type. The way everybody has a way they type. For the gaits analysis is where the way you walk, how you walk. Everybody has a unique way of walking. Some will say when I walk, raise my head. Others will say when I walk, I shake my buttocks, like the way some of you have been doing, the ladies especially. Yeah, I'm sure the guys will bear with me and they know exactly. You know your people, the way they walk. You can see the person from afar and you know that this is the person coming based on the way they work. That is an example of the biometric behavioral biometric. Yes. The video has gotten more than an hour, so it's 1 hour, 30 minutes. Let's just end here and we will continue. I'm going to stop the video. We'll continue, God willing, next week. So tomorrow, what is going to happen is you will meet for the practical. The next week, we'll meet for the continuation of this. If I do get time, I will put up a video and put it up there for you so that we'll be done with chapter 2. But for